third graders. Today we are working on lesson 19, our problem set lesson 19 of unit 7. We are continuing to work with perimeter, although today our lesson kind of shifts a little bit more towards area. So if you have your colored tiles or your little squares, you can use them today. We don't need them. We're also going to be making rectangles and squares. We can use basically multiplication sentences to find them, but you are welcome to grab your tiles if you would like to use those. If we look at our I can statement for today, it says I can construct rectangles from a given number of unit squares and find the perimeter. Our lesson does say that we're going to be finding perimeter, but not really today. So pretty much today we're going to be just finding the area. If we're given a specific area, you can take that number of tiles. Let me just demonstrate for the first one. And if you want to if you do have your tiles handy, you can take out 12. And if not for today, it's fine if you just want to watch. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12. So it says, the directions say to use unit square tiles to make rectangles for each given number of unit squares. So for example, this one says number of unit squares, 12. And then it says to complete the charts to show how many rectangles you can make for each given number of unit squares. The first one is done for you, which is right here. You might not use all the spaces in each chart. So basically, they gave us an area of 12 or 12 unit squares, and we want to make as many rectangles as we can using 12 tiles, 12 unit squares. So we can say to ourselves, what times what equals 12? And if I do that, I know that 1 times 12 equals 12, 2 times 6 equals 12, 3 times 4 equals 12, but we can also use our tiles to create that. So remember, I always said to start with 1. You can always make, like for example, 1 row of 12. So I'm not going to do that right now, but if I could have one long skinny row of 12, right? I could also have 2 rows of 6, which would give us that 12. Trying to put them together quickly here. 2 more. Stuck to my fingers here. Okay, there's 2 rows of 6, which gives us 12 unit tiles, which gives us an area of 12. And I can also so remember last lesson we were saying, okay, 1 times something, we can always use 1. Then we'll try, can we do 2 times something? Yep, we can do 2 times 6 to get 12. And then I'm going to say, can I do 3 times anything to get to 12? Can we? 3 times 4 equals 12, right? So I'm going to just slide this next row down. So there's my side lengths of 3 and 4 because I have 3 rows of 4. So then if I were to keep going and I would say, can I do 4 times something? I already did it. Can I do 5 times something? 5, 10, 15? Nope. Can I do 6 times something? It's already there, right? And once we hit that halfway mark, because 6 is half of 12, we already have used that. So pretty much we've gone as far as we can go. So we can do, and I can even put those little times in there. I can do 1 times 12 to get 12. I can do 2 times 6, and I can do 3 times 4. Okay, so you are welcome to continue to use your tiles through the lesson, or we can just think of our multiplication sentences. I feel like we're pretty good at those at this point anyways. So we're constructing rectangles from a given number of unit squares. If I can get that off of there. Alrighty. So for the next one here, it says number of unit squares is 13. So we want to make as many rectangles as we can that have an area or that's going to use up 13 squares. So what's the one that we're always going to start with? 1, right? So we can do 1 times 13 equals 13. So then we want to think, let's continue to go up our chart. So let's make a chart. Can I do 2 times anything to get to 13? I can't, right? Because 13 is an odd number. So I can't count by 2s, 2, 4, 6, 8, 10, 12, 14. Nope. can I count? So if we did 1, then we said yes or 1, no to 2. So next would be 3. Can I do 3 times anything to get to 13? Can I count by 3s to get to 13? 3, 6, 9, 12, 15. Nope. Next would be 4s. Can I count by 4s and get to 13? 4, 8, 12, 16. Nope. Can I count by 5s to get to 15? 5, 10, 15. Nope. 6s? 6, 12, 18. No. 7s? 7, 14. No, right? So for this one, for 13, we can only make one rectangle. Okay. All right, go ahead and look at the next one. It says number of unit squares is 14. So we want to see how many can we make with 14 unit squares or with an area of 14. So what's the first one that we can always put down here? 1 and 14, because 1 times 14 equals 14. What's going to come next on my chart? 2. I want to try out 2. Can we have us multiply 2 times anything to get to 14? 2, 4, 6, 8, 10, 12, 14. So 2 times 7 equals 14. What would we try out next? 3. Does 3 times anything equal 14? No, because 3 times 4 is 12. 3 times 5 is 15. So that doesn't work, right? How about 4? 4 times 3 is 12. 4 times 4 is 16. So, nope. 5, 5, 10, 15. 6, 6, 12, 18. We're back up to 7, and we already used 7 there. Okay, so once we've hit that point, then we're kind of done with that one, because 7 is half of 14, so we've kind of hit our cutoff point there, right? So how many rectangles can we make with an area of 14? 2. Do you see what I'm doing here, guys? So I'm starting with 1, and then each time I'm just increasing the width in this column by 1 to see if I can count by that number or multiply that number times another number to get to that area there. And if I can, I write it down. I want to make sure I don't have any repeats though. And if not, then I'm just moving right on to the next number. Okay, so the next area is 15. And what's the one that we can always start with? 1, right? 1 times 15. Okay. So after 1, what am I going to try? 2. Can I do 2 times anything to get to 15? Test it out if you're not sure. I can't though, right? Because 15 is an odd number, and I can't count by 2s because it's an even number to get to 15. So the next I would try, I did 1, then I tried 2. What comes next? 3, right? Can I do 3 times anything to get to 15? Test it out. What do you think? Count by 3s and see if you can get to 15. Does it work? It does, because we can do, let's count by 3s. 3, 6, 9, 12, 15. Ding, 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 ding. So I can count by 3s 5 times, right? So I can do 3 times 5, which gets me to 15. Okay. Are there any other combinations? So after 3, what would I try for my width? 4. Can I multiply 4 by anything to get to 15? No, right? Because 4, 8, 12, 16. So that doesn't work. After 4, what would I try? So I did 1, yes. 2, no, didn't work. 3 works. 4 doesn't work. Next I would try 5, but I already have 5 right there, so I'm not going to put it again because I don't want to repeat. If I put 5 again, it would just be repeating. The numbers would just be flip-flopped, so that's not going to count as a new one. After 5, I would try 6, right? Does that work? 6, 12, 18. After 6, I would try 7. 7, 14, 21. That doesn't work, right? And then I could try 8, 8, 16, 24. Is there anything else that we're done, right? So how many rectangles did we make here? 2. If this is still confusing to you, so it might help to have, like, you could do a little sticky note, and we could just say 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll just stop at 10. Okay. So then for your side lengths, for your widths, you could say, okay, can I do 1 times something, 2 times something, 3 times something, and just kind of go down through that to help yourself check. Okay. But if you feel like you really are comfortable with what we're doing so far, go ahead and try those last 3. And if you're still a little bit shaky, you're not quite there, go ahead and try, we can do this one together, okay? So the number of unit squares is 16. So what are we always going to start with? 1, because that's always going to work, right? So it would be 1 times 16. Okay, so that works. Just straighten that up. So if you have this chart, if you're using this on your own, you could even put a check mark there. Okay. Next, I'm going to try 2. Can I do 2 times anything to get to 16? Try counting by 2s and see if you can get to 16. Does it work? It does, right? 2 times what? 2 times 8 works, right? So I can put a check mark there. The next one is 3. Can I count by 3s and get to 16? 3, 6, 9, 12, 15, 18. That doesn't work, right? So you can cross it out. Can I count by 4s and get to 16? 4, 8, 12, 16. So it will be 4 times 4, right? I could try 5 next. 5, 10, 15, 20. Nope, that doesn't work. 6, 6, 12, 18, 24. That doesn't work, right? 7s. 7, 14, 21. That doesn't work. 8s. We already used 8, right? So we're pretty much done with that one. And we're at the halfway point because 8 is half of 16, and we already used that, so we would be done. But if you're still not sure, then you could just finish up your list here. 9, 18, so that doesn't work. And then, of course, 10s doesn't work to get to 16. Okay, so we have these combinations: 1 times 16, 2 times 8, 4 times 4. Okay. Why don't you finish? So if you did this one with me, first of all, how many rectangles do we make? 3. So if you haven't tried any on your own, you can go ahead and make that little list. So this list can just help to guide you to make sure that you are trying all of your possible combinations. Let me make sure I wrote all those numbers there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And I was doing 2 things at once. I want to make sure I didn't skip anything. So try these last 2 on your own if you have not yet. So this one has units, 17 unit squares. So how many rectangles can you make that would, when you multiply the side lengths together, we get you 17. And here we have 18. So do the same thing there, okay? And come back and check with me in a minute. All right, how did we do? So for the number of unit squares, which was 17, the one that we can always start with is 1, right? So 1 times 17 will get us to 17, right? So next I would try 2. Can I do 2 times anything to get to 17? No, because 2 is even and 17 is odd. Can I count by 3s 3 times anything to get to 17? Nope. Can I count by 4s 4 times anything to get to 17? 4, 8, 12, 16, 20. Nope. 5s? 5, 10, 15, 20. Nope. 6s? 6, 12, 18. Nope. 7, 7, 14, 21. 8, 16. No. There's no other possible combinations. If I went down through my list, or if I'm just really good at my multiplication facts, I know that there's nothing times another number that's going to get to 17. So 1 times 17, that is it. Okay. So these are the only 2 numbers that I can multiply together to get to 17. Okay. So how many rectangles did we make? We made one rectangle, okay? And then how did you do for the last one? The number of unit squares is 18. Did you start off with 1 times 18? Good. Then did you try 2 times anything? And if you did 2 times something, what did you get there? Because it does work. 2 times 9. Good. And what did you do next? Can you do 3 times anything? 3 times what? 3 times 6. Good. And we finished our chart, but if we were just to keep going, just to test it out, can we do 4 times anything to get to 18? No, because if we count by 4s, 4 times 4 is 16. 4 times 5 is 20. So we would skip right over that, right? What comes next? We can't count by 5s. The next one would be 6. So we already used 6, right? So 6, 12, 18. 7 doesn't work. 8 doesn't work. 9 we already used, right? So if we're to work our way through that list, and then 10 doesn't work either, okay? So we had 3 combinations, numbers of rectangles that we could make that would have an area of 18, okay? So we had 12 they did for us. There was 3. 13 just had 1. Another one that just had 1, which was 17 that we just did. So these are actually 13 and 17 are examples of prime numbers. I'm going to do like this hashtag symbol. That means number. So 13 and 17 are prime numbers. And that means that for these prime numbers, you can only multiply 1 and itself to get that fact. So 13, we could only do 1 times 13 to get to 13. And 17, we could only do 1 times 17 to get to 17. So there was no other combinations of numbers that could give us that total. So those are prime numbers because you can only multiply by 1 and itself to get to that total. Okay, go ahead and flip it. On the back, I'm just going to get you set up, and then I want you to whip off this line plot real quick because you should be pretty good with line plots. It says to create a line plot with the data you collected in problem 1. The title here is number of rectangles made with unit squares. We'll highlight that title. The number of unit squares used, and an x equals 1 rectangle. So it starts with 12 and it ends with 18. So just to show you, so 12 is the one that they did for us, 12 right here. And they made 3 rectangles with an area of 12. So we would go 1, 2, 3, okay? But we're missing all these numbers in between. So we have 12, we would have 13, 14, 15, 16, 17, and 18. So we can add those in real quick. 13, 14, 15, 16, 17, and 18. Okay. Once you finish that, you can pause your video and then you'll just kind of keep flipping back and forth and looking. So we already did 12. They did 12 for us, and it had 3 rectangles that had an area of 12. Then you would look at 13, and then you would just flip back and see, okay, here's 13, and we only made 1 rectangle with an area of 13 because it's a prime number, right? So then you would just put 1x there. So keep flipping back and forth. This is a good review of line plots for us. So finish filling in your numbers and then go back and forth, pause your video, and then join me after and we'll check our line plots together, okay? All right, let's see how you did. So we did 12 and 13 together. The next one we have is 14. So if I flip and look at 14, we had 2 rectangles that had an area of 14, 1 times 14 and 2 times 7. So that means we would put 2 x's, make sure that our x's are lined up, right? So I can make a line straight across and they're even. Then for 15, we had 2 as well. So these 2 should be right lined up with the 2 of the 14. How are you doing so far? Good. The next one we had was 16. So flip it. We made 3 that had an area of 16. So line them up, the two that are already there. Good. And then 17 and then 18. I'm just going to put those in my head. So 17, we only had one because we said 17 was a prime number. We could only do 1 times itself. And then for 18, we had 3. So 17 is 1 and 18 is 3. 1, 2, 3. And I want to make sure that these all pretty much line up. Let me go across like that. Okay. How do we do? So for 12, we had 3, 13, 1, 14, 2, 15, 2, 16, 3, 17, 1, 18, 3. Good. Number 3 says, which numbers of unit squares produced 3 rectangles? So which units produced 3 rectangles? So 12 did, 16, and 18. So we can fill that in. So 12, 16, and 18. And then the last one says, why do some numbers of unit squares, such as 13, only produce 1 rectangle? So we had 13 and 17 only produce 1 rectangle. And what did we say those numbers are? They're prime numbers. So they only produce 1 rectangle there. So let's put that. So we'll write it in cursive. If you can, you don't have to, but it's good to practice our cursive. They are prime numbers. So what that means is we can only multiply that number times 1 to get that total. Okay, good. So that's our lesson for today, guys. I think you did a super job. It was a good review of line plots and really a review of area as well, right? To think of what numbers we could multiply to get that area. So tomorrow we'll kind of pick it up and bring perimeter a little bit more into it, okay? So I will see you tomorrow.